This video will give you an introduction to two-way within subject designs. Within subjects designs are designs where each participant is tested under multiple conditions. So each level of your independent variable, where your independent variable is what establishes the groups that are being compared when you're doing mean comparisons in ANOVA. But within subjects designs is that every single participant is in every single level of that independent variable. And this is what the equation looks like for this type of model. Very similar to the between subjects designs, but slightly different based on the variances that are being used. These within subjects designs are also called correlated error models, but the one that you would most likely hear is repeated measures designs, or this is can also sometimes be called longitudinal ANOVA. So this goes by several different names. But regardless of the name, the biggest point is that every participant is in every level of your independent variables. So each participant is in each group. So now your ANOVA is more like a paired sample t-test than an independent sample t-test. So for the between subjects designs, you have independent groups where the participants in each group are only in one group. Whereas with now the within subjects design, it's like a paired sample t-test where we use paired sample t-test for like a pre-test, post-test comparison. And this is where every participant is in both groups. It's both in the pretest and in the post-test. But now we have 3 or more of these groups to be able to do this within subjects designs ANOVA. And so the subjects are providing multiple values for the dependent variable. And so for each level of the independent variable, each participant will have a value for the dependent variable. So the means of the dependent variable are still what's being compared across the groups, just as in any other ANOVA design. But now you have each participant is at every level of the independent variable. And so this repetition can be over time, and most often we see it over time. So it's 3 or more time points where each participant has a value of the dependent variable at each of those time points, but it could also be over treatments where it's like a leveling or a stacking of treatments, or it could be something where it's the increase of sessions, so the number of sessions, but you are measuring the dependent variable at each session. So then session 1 dependent variable value could be compared to session 3 dependent value and look and see if there's mean differences across all these different treatment levels. So you can have two-way or two-factor within subject designs where you have two independent variables that are establishing different levels for the dependent variable to be compared. It's also called doubly repeated because you usually have both factors that are being repeated across the levels. So the dependent variable is repeated twice. That's doubly repeated. It's repeated across factor A levels and repeated across factor B levels. And so some of the examples that you could have for a two-way within subjects is you could have a treatment level, so multiple treatments with time. So you could have your two factors be time and treatment. And you could also have where you are looking at like type So here, this example is drug type and dosage, um, which would also um, be like exposure level. Um, so you can combine those two and be able to look at a two-way within subjects design that way. The only one that you don't see because it gets too complex is time with another time variable. So both factors being time, you usually will not see. These two-way within subject designs get complicated in their interpretations because you have these two factors, but it's nearly impossible to interpret when you have two time factors. So similar to a two-way between subjects designs, you have these multiple effects that you have to take into account. The difference here is that within subjects, you have both your effects from your factors, but you also have your subject variance because every subject is included in all levels of your independent variables and is essentially being compared to themselves. And so you have your main effects, where it is for each of the factors and then also your subjects. You have your interactions, which include the interactions or your pairwise interactions. So interactions pairwise. And this includes when you're looking at the two factors interacting with each other, but then also you have to look at each of the factors interaction with the variance of each individual subject or participant as well. And then you have this three-way interaction. And so this is where these two-way within subject designs get very complicated, and you usually do not go beyond a two-way within subjects design. Because for a between subjects design, you have to have three factors to be able to get to this three-way interaction. But you automatically get this three-way interaction with within subjects two-way design because you also have to take into consideration the variance of the subjects. So then you do get F ratios for these different effects, and you can get the F ratio for each one of your factors because each one of these is like a one-way within. And so this is one way within for factor A, and this is a one-way within for factor B, but then they both are included in this three-way interaction variable here. And so remembering that for any of the within subjects designs, your error term is going to be a different type of calculation. And so here, the error term, get a different color here, where this would be considered the error term. It's taking into consideration the interaction between the variables, but also this three-way interaction between the factors and the subject.